This is lesson 26 of the Quantum Mechanics, a mini lecture series. So having talked about the first complete version of quantum mechanics as a theoretical construct, an Austrian-Irish physicist named Erwin Schrödinger actually despised this new theory, okay? That's highly mathematically abstract with no pictures or visualizations. So he developed another version of quantum mechanics rather than the matrix mechanics put forth by Heisenberg and further developed by Born and Jordan. And he based it on de Broglie's concept of matter waves from several videos ago. And he wanted to return to classical physics. Okay? He wanted these continuous visualizable aspects. But before I can talk about Schrödinger, I have to go over some mathematical interlude if you wish. I need to first go over the basics of wave physics. So let me first introduce the idea of angular frequency and wave number. I'll start with angular frequency. So angular frequency, so if you recall, frequency is how many complete cycles or vibrations occur in a given time period per second, typically. Suppose you have a circle, you have a point going around a circle. Angular frequency, given by the symbol omega, this is the Greek symbol omega, it's angular frequency, tells us how fast the point is moving around the circle. And it's related to the regular frequency as follows. Omega is just 2 pi f. Okay, the 2 pi comes from the circumference of a circle. If you recall, c equals 2 pi r. And we're going to take the radius to be 1, in this case, 1 unit. That's why we get 2 pi. And if the point completes one full revolution, one full cycle per second, the distance it travels in 1 second is just 2 pi r. Distance traveled in 1 second, okay, if it makes one loop. And I want to introduce the idea of something called a radian. Suppose you have a 1 unit radius, okay, 1 unit. Radian is a measure, a radian, so you've got degrees and you've also got radian, okay, to measure angles. Radian is a measure of an angle that's equivalent to the length of an arc. Arc is a segment of a circle on the circumference, which is equal to the radius of the circle, right? So this arc is equal to the distance from a point to the circumference, which is the radius, okay? That's a radian. So we're going to take one full revolution around the circle to be 2 pi radians, right? 2 pi radians is equivalent to 360 degrees. Now, if a point completes one full revolution, I should say, per second, it moves through an angle of 2 pi radians, 2 pi radians per second, right? So therefore, angular frequency, omega, is just 2 pi radians in 1 second. Okay, distance traveled in 1 second is this. Right, so therefore 2 pi radians is just, also written as RAD for short, radians, rad, omega times 1 second. Okay, this is d for distance, that's the distance traveled. Omega is like the velocity, the speed. Second, that's a measure of time. Okay, so therefore, we can conclude that 2 pi radians is the same thing as the frequency times 2 pi r equals to omega times 1. Okay, taking r to be 1, we therefore get frequency, I should say omega, is just 2 pi f. That's where this relation comes from. Just a quick derivation. That's angular frequency. And I'll talk about wave number in the next video, but that's the idea of angular frequency. Okay, it's basically the normal frequency multiplied by a factor of 2 pi because we're dealing with circular motion.